everyone. Thank you for coming in, and also people who's joining through live stream. Welcome. First question I would like to ask before I start off is how many of you have built apps with React Native which is in production? Raise of hands. Good. And out of people who raised your hands, how many of you have done custom animation, custom transition with? Okay, that's 2. Okay. No worries. I think what this talk is basically shared element transition with React Native. I'll try to keep it as basic as possible so that everyone here can relate to what I'm talking. Before I start, I'd like to give my introduction. I'm Narendra. I work for a company called Booking.com here in Amsterdam as a front-end engineer. So the first question, what is shared element transition, right? So before I answer that, you need to know what is transition. So when I was thinking about what do I actually talk about when I say what is transition, I came up with this definition, which means transition is an animation which guides users to focus on what you want, right? So that's one smaller definition which I could think of, where you could say that transition which helps users to focus on a particular item. So to give you an example, this is my Instagram profile, which is the profile screen, and when you click on any of the images, it takes you to the photo screen, right? So the way the image is being transitioned into the screen makes you focus on that particular item, and when you hit the back button, it goes back in the reverse. So it gives you the context on what you need to be expecting when you hit the back button, right? So what are the other advantages of having a transition? So context is a very important aspect for any users who is using your app. So no user would like to be lost while using your app, and so when you're clicking on a particular item or when you're performing some actions on an item, if certain things changes immediately, the users get lost. You don't know what has happened. The transition gives you the aspect of predicting the next screen or next element in the screen, how it needs to be animated. Also, while transitioning, there are 2 very important animations which happens. When one is the entry and the exit, which means the second screen enters the viewport, which you could say, and the old screen exits a particular viewport. So you need to handle these 2 particular animations well. In that case, the entire transitions would be done well. So now coming back to this question, what is shared element transition, right? So now you know what is transition. To give you a definition for shared element, as the name suggests, it is the same element which has been used between 2 screens, and it has been moved or changed from one size to another, from one screen to another, right? So it's the whole transition which is happening, but the element which has been shared between these 2 screens. So now when you get the definition, I'll give you an example which I built, where this is a grid, photo grid app, where you click on a particular photo and it goes to the detail screen. You hit the close button or the back button, it goes back to its actual position. So you can predict whenever you hit the particular image, you can predict what to be expecting in the next screen. So what's the advantage? So it gives you the continuity between the 2 screens. That means the screen never breaks. You kind of feel that you're still on the same route or the same screen, but actually in reality you have moved from one route to another. So here you could see that once I'm clicking from one image to another, you kind of feel that I'm in the same layer, but you're not. You've actually gone to a different route, right? So it gives you that continuity, and it forces the human eye to focus on what you want, or focus on the context and the representation. So you click on a button and the button grows on to become some image, so you already know what that particular item is in the new screen. You don't really have to teach the user what that item is and how it performs. So now that we have given the introduction about what is shared element transition and everything, I'd like to show some few good examples on a day-to-day app which is there, but you kind of have ignored this animation. One is the print test, where you click on a particular any of the pin, it grows on and it becomes a full detail screen. That is, the entire pin becomes in a detail screen. And when you hit the back button, it goes back to its actual position, right? So these are a very small transition, but it gives you a lot of meaning for the user. Another one is a Uber, which you've pretty much been using for a while. You hit on the search and it goes to the search screen, and you kind of feel that it's the same route, but in reality it is a different route altogether, right? Another one is a Snapchat. So you click on any of the stories there, it opens in a big screen, but when you drag it down and when you leave it, it goes back to its actual position. So what's happening here is it's all different routes, but but you could see that the way it is transitioning from one screen to another makes you feel that you're still in the same, the app is lighter, and it gives you a good feeling, good experience for the user. So now we have all the basics told. First question, does React Native support shared element transition? How many of you think it does not support shared element transition? Okay, that's a good one, because while I'll be here on the stage talking about how to do it in React Native, right? But in reality, React Native does not support shared element transition. And to explain why, let's say you have an app, and this actually applies for React as well. So let's say you have an app and you have two routes, which means you have a grid route and a detail route, and both of this route have its own text and image, right? And let's say the text between these two routes has been shared, or the image between these two routes has been shared. There is no way in React you can tell that don't destroy, while moving from grid route to the detail route, don't destroy this text or the image and reuse the same component here, but just change the props, right? So you can't tell anyway. There is a ways to do it, but it gets very complicated. But there's no very straightforward way that this component is used between these two screens. Please do not destroy it and just change from one size or one position to another and using the same component. So it will destroy it and it will redo it in the new route. So that's the reason why it's React Native does not support, or for a matter of fact, React does not support shared element between the two screens, right? So what's the goal between these talks? Now, React Native does not support shared element, and I'm going to talk about how to do that with React Native. So the goal is to build this app as we go along. So you guys would be part of this particular session where we will be building this entire app and building the shared element as we go. So the two main aspects, one is using pure JavaScript, which means why? Because why not? Everything these days we can do it with the JavaScript, and also because I don't know Objective-C and Java to write the native code. And also we don't need any compromise on the animation. We need to have a reasonably smooth animation, trying to achieve 60 FPS. So that's the ultimate goal, right? Okay, so now you've seen what we are trying to build. So let's dissect the animation. Let's have it into multiple breaks and see how it performs. So the first screen, which is the grid screen, which fades out, okay, like I spoke about, is the exit transition. And in the new screen we have the detail section, which fades in from the bottom. So that's the entry transition. And between these two screens you have this image, which is this shared, so which animates from one position and from one size to another. So these are the three animation. One is the exit, one is the entry, and one is the shared element, right? So now you saw it. Do you think was the image shared between these two screens? Was the same image being shared between these two screens? What do you think? No? Is that because you think React Native does not support? Yeah. But anyways, that's the right answer, because React Native does not support, but also I didn't want to complicate it. So the two element which you see here is not shared, and I'll explain you how we are achieving it. So like I spoke about, while dissecting images, you have exit, entry, and the shared element. But what actually is happening here is detail screen has its own image, and then grid screen has its own image. So while animating, you get another transition layer in between, which animates and disappears. So this transition layer would have just the image, and it kind of makes you feel that this particular image has been animated, and it disappears at the last minute and the last image appears. So we will go through this entire section of implementing that, and you'll probably get what I'm talking about. So things to know. So people who have not used React or done any animation with it. So I'll be mostly talking about few APIs here. So I'm gonna be using this animated API of React Native. So when you use animated API, I need to create a value for that animated API, which here I use animated.value, and for now I've set it to 0. Okay. So this value changes from one value to another, right? So let's consider this as the CSS transition. So you change from one opacity of 0 to 1 at the duration of 3 seconds or duration of 300 milliseconds. So the value changes from 0 to 1, right? So consider that as like that, and I listen to this value using the interpolate API, where at a given input value of 0, the output value is 1. So consider this as like a graph, or if you have used the keyframe animations in CSS, where at the 0th position the opacity is 0, at the 100% the opacity is 1, and the entire graph is automatically done, right? So you get the entire graph. So this is the same thing like that. The input range of 0, you have the output range as 1, and at the 1, which is 100%, the output range is 0. Okay, so you basically just change the value and you just listen to this. Okay, so let's get on to the implementation. So we have two screens, like I mentioned, the grid screen and the detail screen. You click on this image in the grid screen, it takes you to the detail screen, you hit the back button in the detail screen and you comes back, right? So everyone's just following. So what happens when I do it without transition? Just that implementation. You see, I click on an image, it opens the detail screen, just a random state management. I just change the state, it renders a new component, right? Okay, so like I mentioned, while I'm doing an image click, I have two sets of animation which I can perform. This is the exit of the grid and the entry of the detail screen, right? So let's first get that and let's talk about shared element later. So let's add the exit transition. So exit transition is added to the entire screen, which is the entire grid screen, right? So which means by default, the opacity of the entire grid screen would be 1, and when I click a button, it needs to change to 0, right? So I'm just gonna listen to the animated value like I mentioned earlier. So when the animated value changes from 0 to 1, set the output range from 1 to 0, right? So the opacity is 1 at the start and it changes to 0. And this particular thing is triggered with the animated.timing API, which I just mentioned earlier. And this particular animated timing API is executed on the click handler of the image. So when you click the image, you change the animated value to 1, and that is particularly listened to the opacity. These are declarative APIs. So that is listened to the opacity style, and the style has been changed. So if you see how it actually looks, if I just do this part, is the entire grid screen disappears in 3 seconds. So we got what we wanted for the exit, and let's do the entry transition. So in the entry transition, we do it only for the section, which is just the detail section, because the other image we're going to handle it separately because it's shared element. And by default, the transform is the translate by its position 0. So which means at the given position, I need to translate from the 100 position, which is at below that, and translate to the actual position. Which means you can actually relate this to the keyframe animation, which I mentioned, which means at 0th position, at the 0%, the translate y is 100, at 50% it's still at 100, and at 100% it's at 0. So which means at the last 50% it animates from the bottom. Okay, and this again is triggered by the same animated.timing which I've added to the click handler. So how does it look with both entry and exit transition? You click on the image, it's faded, and that particular screen appears in the between. So you can ignore the image which abruptly appears in between. So we've not added any transition to it. We'll handle that later. So we got what we wanted. So now add the transition layer which I spoke about. So to give you a bit of a context of what I spoke earlier, we have grid screen and detail screen, and what we need to do is we need to animate this particular image which is in the grid screen, and we need to animate it to the detail screen from the given position and the size. Right? So what I told was I'm adding a transition layer in between which would particularly do it, right? So what transition layer, when I click on a particular thing, the transition layer needs to know which image and what size are there, or what position are there. So I will know in the grid screen what size and position were, and in the detail screen I'll pass them to the transition layer, and in the transition layer I will animate from the given actual size to the destination image. So this is the whole concept which I'm going to be doing. Okay. So let's animate now. So since we know that we are changing from one position and from one size to another, I'm just going to change the CSS property which is width height for the size, and left top and left for the position, right? So what am I doing? So I'm setting in the transition layer. So now whatever I'm going to do is only doing in the transition layer. So in the transition layer, I'm going to render the image in the source width and height, which is the start width and height, and the start page X and page Y, which is the start position. And I'm going to change that to the different, which is I'm going to listen to that animated value which I told earlier, where at the 0th position the width would be the source width, and at the 100th position it will be the destination width. And the same thing I'm going to do for the height, which is the source width and the source height and the destination height, and that continues for the position, which is the left, and also for the right. So what you're going to see here is once I click on that image, this particular entire declarative API has been set, and the entire graph has been set at a given input value. This is the output value, and it executes. So let's see how it looks. Do we get what we wanted? So you can see when I do that, the size of that changes and the image sets up. So this is pretty much what we wanted, right? But I can't really say this exactly works, is because this is not the real app. So for that to be done, I need to do the performance analysis of this to see how performant it is on the real world app. And since this is not real app, I will fake it by making it a simulated to make it a busy app, and by adding it to this code, which means at every 1 second I'm going to run a for loop, which is forever, and let's see what happens. So this is my app which I implemented a while ago with the busy app. So as you can see here, there's certain frames which has been skipped, right? And that's just because I made the JavaScript thread busy. And to know why that is happening is, let's see. So when the click happens on the native thread, and the serializes the entire animation nodes, which is the width changes from one size to another, height changes, the size changes, and all of that. And it uses the request animation frame as the animated library. So on every frame, it needs to know when to trigger the new size and a new animation. So it uses request animation frame here, and it gets the new input value. Based on the new input value, it gets the new output value. It sets that, it passes as a props to the views, and the view has been updated using the set native props, and that value has been passed over the bridge to the native thread, and the actual native thread has been updated. So as you can see here, on every frame, this particular section has been executed for every frame, right? And most of the work has been done by the JavaScript thread. So that explains when I made the JavaScript thread busy with a loop, it started skipping that frames because it didn't have enough memory to do it, right? So how do we solve it? So React Native in the month of February kind of launched another API called use native driver, which is very simple to use, which means you just need to add another object here, other value, which means use native driver true. And what it actually does is it moves most of the context to the native thread. So that is, click happens, it serializes the node and serializes and passes it to the native thread directly. And here it uses the native driver, which is separate for iOS and Android, and it generates a new input value, it generates a new output value based on that, and the native view is updated. So as you can see here, most of the work has been transformed. But there is a problem with here. The disadvantage with this is it can animate only on the non-layout properties, like transform and opacity, but it can't animate on the layout properties like width, height, top and left, which is what I have used. So none of the implementation which I've used earlier would work here, right? So we got to change the entire implementation which I used to make it work. So what am I going to do is I'm going to implement the same thing but using transform and use native driver to get that performance. So if I have to change from one size to another, I'll use scale for it. And if I have to change from one position to another, I'll use translate X and Y, right? So that's the alternative way of doing it. So again, coming back to this, I have a grid screen, I have a detail screen, I need to change from one image to another. I'll just go back a bit. Yeah, I need to change from one size to another and from one position to another. But since these two images are not in the same aspect ratio, I need to bring them in the same aspect ratio, right? So because I'm using scale, I can't really depend on the width and height. So the scale happens from the same aspect ratio. I can't change the aspect ratio with the source and destination. And I will here use the aspect ratio of the source and render it in the destination. Also, I need to render the source image first the destination image. Earlier I rendered the source image, right? Now I need to render the destination image, because if I scale from small to big, it will pixelate. Instead I'll scale the bigger image, make it smaller and animate it from there, right? So if I scale it from smaller to bigger, it just pixelates. So that's the main reason for that. So to bring it to the same aspect ratio, these are the aspect ratios, easier, width by height gives you the source aspect ratio and the destination aspect ratio. And the difference between that, if it's greater than 0, it's a landscape image, that's the width is bigger, and if it's less than 0, it's a portrait image, which is the height is bigger. So you just need to find new width if it's a landscape image, and if it's a portrait image, you need to find the new height, and that's the only difference. So for the new width is source aspect ratio into the actual height, and divide it in the for the height. Okay. So this is what my image looks. It's the same aspect ratio, as you could see the source image and the destination image is rendered, but this is not exactly what I wanted. As you can see here, the position is different, right? And it's just because the extra width which I've got, half of it I have to subtract it with the existing position. So then it moves to the center. I just need to bring it to the center, right? So what I'm going to do is, for the landscape image, I'm going to do that new width minus the destination width, which is the difference of the new width, new width which I've got. Half of it I'm subtracting with the actual position, which means it moves to the left. And the same thing I'm going to do with the position y, which means it moves to the top and it all comes to the center. So when I do that, it actually sits to the center. So this is exactly what I wanted, right? So now, since it's in the same aspect ratio, for me the scaling is much easier. I don't have to worry. So it's the initial scale is just the source width by the new width which I've got, right? It's as simple as that. So if I implement the scale, this is how it looks, and I've got the image size what I wanted, but now I have to calculate the position, which is the translate x and y. So one thing we all know is scale happens from the center, right? It happens in all the direction, x and y, which means if I have to translate, what I right now know is the position in the translate top left corner. So in that way, I have to translate it from the center of the image, both from the source and the destination. So in that, otherwise it'll really have a weird transition. So for that, I need to find the center of both these images, which means it's just the existing width, and add half of it width add to the positions, I get the exact center. So it's as simple as that. So I have the new translate x and y for the source, which is the existing position. So it's the center of the image, and the same thing I'm going to do for the destination, which is the center of the destination image. Difference between that is what I need to actually transition. So I now have the scale position, which I have, and then I have the new translate x and y value. So now I just need to implement that. So the only difference which I am doing here is the same trigger which I am using, this animated.timing, but only difference is the use native driver which I am using here, which is a way to get a performant animation. So like I mentioned earlier, we did for source. Now we're going to do for the destination. We're going to render the bigger image, and the destination width and height, position x and y. But I'm going to replace this entire thing with the transform, right? So I'm going to do that with width, height, left and top, and then I'm going to say that translate x, the opening translate y, and then it animates to being at 0th position, that the 0 actual value, and the same thing for the y, and the scale from the actual smaller scale to the 1, which is the default size of it. Okay, so how does this look? So when I click on the image, this is exactly the same transition which I got, but I can't really say it works until I do the performance analysis. So I'm going to do the same code, same for loop I'm going to add, and this is how it looks. So you click on the image, it animates without missing any frame. And the main reason why it didn't miss any frame is because most of the computation is happening on the native thread, and the loop, the set interval and the loop is running on the JavaScript thread. So there is nothing which blocks the animation. So this is what we have got right now. As you can see, there are a couple of things which we need to work. One is the image in the background, which suddenly appears, and as you can see, the source image which has been clicked is not been disappeared. That means it still doesn't feel the shared image, still doesn't feel it's the same image which has been animating, right? So let's do that. Let's hide the source and destination image during the transition. And what I would do here is, now you could have had a hang of the animated value when I interpolate. At the initial 5% or 0.05%, I'm going to animate, where I'm going to change the opacity of that image from 1 to 0. Okay, so the moment you click it, the opacity is 0, which means that you feel that the image, that actual image has been disappeared and this image has been animating. But I'm going to do it differently for this destination image, where at the last part of the animation, I'm going to make the opacity to 0. At the 0th, it's 0. At last 90.99%, it is 0, and the last 0.05%, it actually changes. Okay. So if you could see here, now you can see, click on that image, the source image has disappeared, and the destination image has disappeared. So the transition layer just transitions and disappears, but you can't really feel it, because the moment it disappears, the actual image is actually there. The actual image appears there because it appears in the last part, right? So yeah, this is how you fake the shared element transition. But there is last one thing I need to handle before I end this talk, which is handling the back button. So as I mentioned, I have set the entire graph, like at a given input value, this is the output value for the animation, for the opacity, for the translate X, for the translate Y. So what I did was I changed the animated value from the 0 to 1, and when I hit the back button, I just need to change the value from 1 to 0, and the entire animation happens in reverse. So because I have said that this, if the animated value is at this particular position, this is what the output value of this should be. And that's all I have done. And when you, when you click on that image, it animates to the actual position, and when you hit the back button, you can see the entire animation happens in reverse. And there is no other code to be written to this, just change the animated value and the entire animation happens in the reverse. Yes. That's it. I've written a small blog post on this a while back. It's on my Medium. And yeah, you can read, it's a detailed one. You can read that, and most of my talk has been covered in that post. And also the code for this particular app has been put on GitHub. You can fork it, you can build anything on top of it, you can create issues if you find it. Of course you'll find it, but yeah. And also I have this entire presentation on speaker deck, which I will also share on the meetup group post, so you can find it there. And also how many of you have used Expo? Yes, so now you know what it is, but people who don't know what Expo is, there's an app called Expo on your App Store. You can install it on App Store and Play Store, where you can scan this QR code and you can use this particular app which I built, which I showed you throughout my talk, and use it on your both Android and iOS phone and test it out yourself. That's it. This is my Twitter handle. My DM's open. You can ping me if you have any questions, or yeah. That's it. Thank you.